Let's think real quick. Are there ways to do this problem that we just did without trig identities? Well, remember we had a shortcut about the sine of a linear function of x. Do you remember what that shortcut was? It was 1 over a times the integral of sine is negative cosine of that linear function. So can we use that? It's one of our favorite shortcuts. Well, this doesn't have a sine squared, right? So this only works for a plain sine wave, not a sine squared or square root or anything. So that shortcut doesn't have a squaring. Another way to think of it is we saw that sine squared is never negative, not a big surprise, but this sine wave could be negative. Integrating one thing that's never negative is unlikely to give you the same answer as integrating something that is negative half the time. So I have to kind of give up on that one. Can we use u substitution? That's another one of our favorites, right? What would you try? Maybe u equals omega t, du equals omega dt, and then 1 over omega du equals dt, and you get the integral of sine of u squared times 1 over omega du. That's basically what we were trying to do here, but we still have that squaring. It's still not going to work. Anything else we can try? Anything else that's kind of an inside function? Well, we could try sine omega t, then du equals cosine omega t times omega t prime dt because of the chain rule. And then we don't have a cosine in the integrand to combine with the dt to give us du. So it just ends up not working. What's another integration technique? Maybe integration by parts. It ends up not working. You could say I kind of have two versions of sine. This is sine omega t times sine of omega t, and then let one of them be u and the other one be dv. It just leads to a loop as far as I remember. So we really do need that trig identity that we just used. All right, let's go on to another kind of problem in this chapter.